Hello, I'm Mr. Kelvin from Udukea Institute, and today we have presentation based on physics, Form 1, and our topic to be discussed today is force. And subtopic to be covered within this topic, we have almost 3 subtopics. Subtopic number 1 is concept of force, and the subtopic number 2 is type of force, and the last subtopic to be discussed is effect of forces. So now let's start with subtopic number 1, which is concept of force. Within the concept of force, we will discuss some various concepts which include explaining the concept of force. What does the force mean? Also, we'll discuss the SI unit of force. Now, let's start with the concept of the physics based in our topic, which is force. When we say force is an influence that change or tends to change the state of rest or uniform motion. Or force is a push or pull experienced by an object. It is measured by a device or instrument which is called a spring balance. So force is a push or pull experienced by an object, and it causes a body to change in its original position or in its state. So let's state the unit of force. As we know, force is measured by using a spring balance, and the unit located in the spring balance is what we call Newton. So the SI unit of the force is Newton. Things to note: a branch of science deals the effect of the force on matter is called mechanics. When we study mechanics, is a branch which deals with the effect of the force on the object, on the matters. So now let's discuss the type of forces. Concept to be discussed in this subtopic. This is subtopic number 2, which is concept of the force. So the types of the force. We already discussed the concept of the force. Now let's discuss the types of the force. Things to be discussed in this subtopic include identify fundamental types of force. We look how many fundamental types of force. Then we will describe each property of the force we identify based on fundamental type of force. Now, type of force. There are 2 types of force. The first one is fundamental forces, and the second one is non-fundamental forces. Let's start with fundamental force. When we say fundamental force, is a force in which the 2 interacting objects are not in physical contact with each other. So when 2 bodies are interacting but they are not in contact, the force which exists between them is what we call a fundamental force. Fundamental force is the basic force in nature that cannot be explained by the action of another force. So fundamental force is a force which exists in nature, and they cannot be expressed with any other kind of force. Sometimes fundamental force is also called interactive force or non-contact force or action at a distance force or field force. Those are other names of fundamental force. So fundamental force, it have no contact between other forces, but it is force exists between interacting objects which are not in contact or in a physical contact. So type of force based on fundamental force. We already discussed that a fundamental force is the one which body interact but they are not in physical contact. So now let's look the type of fundamental force. There are 4 fundamental forces to be discussed here. The first one is the force of the gravity. also electromagnetic force, and strong together with weak nuclear forces. Now let's start with force of gravity. Sorry, there is spelling error here. Instead of F, we write G. This is force of gravity. As we say, gravitational force is a force pulls object towards the planet. A gravitational force is a force which pulls the object towards the planet. For example, all objects fall down if we throw up due to force of the gravity is pulling the object towards the Earth's surface. As we say, gravitational force is a force which pulls the object towards the planet. The planet we say is about Earth. So when you throw either a stone or an object, it is forced to return downward. The force which causes that object to return downward is what we call gravitational force. It is represented by the letter G, a small letter G. It has constant value which is 10 Newton per kilogram or 9.8 Newton per kilogram. Those are values of gravitational force. This is approximated value, but this can be found through the experiment. So now let's discuss that gravitational force. It is also called a weight. As we know, weight is equal to mass of object times the gravitational force, where W is equal to weight and M is equal to mass of object, G is equal to gravitational force. That is how you can find the weight of an object, by using the constant which is gravitational constant. So let's discuss what are the properties of the gravity. What are the properties of force of gravity? Or how gravitational force have differ from the other kind of the force. We look on the property of each. The first property, we say it is always attractive. It attracts the object towards the surface of the Earth, or it forces the object to return downward when it is thrown upward. Also, weakest force among other force. Gravitational force is the weakest force among others force. Also, it is the central force. It acts on the object along line joining the center of the object and the planet. We say gravitational force is the center force. It acts on the center of the object. Also, it operates over very long distance. Gravitational force operates over a very long distance. For example, a rocket moves from the Earth to a planet X. A rocket moves from the Earth to a planet X if its weight was 10,000 and 3 Newton on the Earth and on the planet X respective. Means when that object was on the Earth, its weight was 10,000. But when it moved to planet X, its weight became 30 Newton on the Earth respective. Then determine the gravitational force on the planet X. We know the gravitational force on our planet, which is Earth, is equal to 10 or 9.8 Newton per kilogram. Now let's find the gravitational force which acts on the planet X. We didn't know the gravitational force on the planet X. Its value is equal to how much? So now let's see. Do some calculation to check what is the gravitational force in the planet X. As we say, we are being given the weight of object when it is on the Earth, which we will term it as WE, was equal to 10,000. But on the planet X, weight was equal to 30, which we term it a WX. But we know the Earth's gravitational force which is equal to G at the S is equal to 10 Newton per kilogram. But also mass of the object we didn't given. Also at the planet X we are not given the gravitational force. Now the first step is to calculate the mass of the object, because the mass does not change. When you move from the planet X to planet Y, your mass does not change. But what changes is weight of that object, because the gravitational force varies according to place you are. When you are in planet S and when you are in planet, let's say Jupiter, your weight will vary. So, but mass will remain constant. So, the first step is to find the mass of the rocket. How we can arrive to the mass of the rocket? We know weight of the object is equal to mass times the gravitational force. But we are being given the weight of the rocket when it was on the Earth's surface. It was 10,000, but we have a gravitational force on the Earth, which is equal to 10 Newton per kilogram. So now let's find the mass of the object. As we know, mass will be equal to weight of object in Earth divided by gravitational force on the Earth, which is equal to 10,000. Then you divide by 10 Newton per kilogram. You will get 1,000 kilograms. So the mass of object initially on the was 1,000, and that mass, when it moved to planet X, the mass does not change. So now let's find the gravitational force. We already get the mass, which is not changing when the body moves from a planet Y to planet X, or when the body moves from planet X to planet Y. So now let's find the gravitational force when the object is at a planet X. We know the formula of calculating weight is equal to mass times the gravitational force. So, but now in the gravitational force, we will put a gravitational force at a point X, which is equal to Gx. So now Gx will be equal to weight of object divided by mass. Weight of object in a planet X, then you divide by mass, you will get 30 divided by 1,000, you will get 0.03 Newton per kilogram. So the gravitational force on the planet X was 0.03 Newton per kilogram. That is how you can find the gravitational force of any planet. So now let's discuss another kind of force, or another type of force, which is electromagnetic force. When we say electromagnetic force, is a force associated with production field due to movement of electron, include both electric and magnetic force. We know electromagnetic force is a combination of electric and magnetic forces. When they combine together is what we got electromagnetic force. So if the force arises due to two effects, the first effect is effect of electric current, and the second effect is the effect of magnetic field or magnetic forces. So when they combine together, we got electromagnetic force. For example, formation of water molecule, also formation of atoms. We know atoms attract each other due to electromagnetic force. So when the molecule are formed, the molecule of water is a result of atomic interaction, or atom interaction, and the interaction is being caused by electromagnetic forces because they are being attracted. So in two charge placed, another example, in two charge placed near each other may attract unlike charge, but all repel like charge. We know the law of charge, when we have a like charge, they will repel, but when we have unlike charge, they will attract each other. The reason why it repel or why it is attracted is due to the force which is called electromagnetic force. So electromagnetic force forces two charge which is unlike to attract. Also, electromagnetic force causes the like charge to repel. Let's see the property of electromagnetic forces. The first property, it may be attractive or repulsive in nature. As we already see that repulsion is a result of electromagnetic force, and the attraction is also a result of electromagnetic force. We say electromagnetic force, it is a center force. Also, it is stronger than a gravitational force. When you compare the strongest of the gravitational force together with electromagnetic force, we see that electromagnetic force is more stronger than gravitational force. It is a long range, means operate over a very large range. Electromagnetic force, it operates in very large range as compared to gravitational force. Okay, now let's discuss the another type of fundamental force, which is a strong nuclear force. When we say strong nuclear force, is the force which holds the constituents of the atoms in a nucleus. It acts within the nucleus of atom. Also, for example, nuclear energy plants force obtained from the splitting or fission or fusion. When we say fission, is about combining things together, but fusion is about splitting them. So nuclear force exists when you split the object, there is fission, or when you combine them, there is fusion of nucleus of the atom. So the nuclear force or strong nuclear force, it holds on the nucleus of the atom. Property of a strong nuclear force, it is basically an attractive force. A strong nuclear force is an attractive force. We say also it is a short range or operate only up to a distance of the order of 10 up to 14 meter. So the force which operates in a short distance is what we call a strong nuclear force. It operates on a distance between 10 up to 14 meter.